Hey guys, and welcome to Functional Print Friday. And welcome back to my basement, I guess, this week. We normally shoot out in my shop because the lighting is so much better out there and it's also much more quiet, but we really need to take care of some stuff in the basement this week. So earlier this year, we designed and 3D printed a custom bracket that holds the fume extraction fan against one of the joists down here in the basement, and then those fumes actually get routed outside the house. And I ran some flexible duct over here, and we also designed and 3D printed a reducer, and then this just drops down and connects to my laser cutter engraver. Well, I never really considered this permanent or finished, as evidenced by the fact that I didn't even cut the zip ties. And there's several issues with this, and we really need to resolve them. When I put this in, I put in one of those like one-way flapper valves so that when the fan was off, hopefully the spring would hold that shut and we wouldn't have air coming back in here. Well, that's not working so great. In fact, the other day, the reason this is disconnected is because I came down here and there was actually some condensation inside the enclosure for the laser cutter engraver. And I realized what's happening is it's always cool down here in the basement, and warm air from outside was coming, was basically backflowing in here and coming into this, and then it was getting cooled off from the cool air down here in the basement, and there was droplets actually condensing inside of here. I disconnected it as soon as I realized what was happening, but now we have a new problem because it smells like a campfire down here in my basement because air is still backflowing through this. So we clearly can't count on that spring-loaded flapper valve that's installed up by the fan. So I think what I want to do is design something that physically blocks off the flow of air through this fume extraction system, except for when we actually want air to flow through it. It's going to be an added step. Right now, I just tap this button down here and that turns on the fan, and it's convenient because it's right here by the laser cutter engraver. But I think in addition to pushing that button, we need to add something that physically blocks off the flow of air. And we don't need to reinvent the wheel. I think we can use a similar design to what gets used in dust collection systems for woodworking. But I would like it to mount to the wall. I've already got this 2x4 that is anchored to the foundation of my house. I used to store some stuff up here and the bungee cords kind of held it in place. I already sort of reused that to just keep this against the wall here with these bungees. But I'd like whatever we design to physically mount to this so it is stationary. And the other thing I want to do is, originally we had a reducer up here that drops from the 4-inch to, I think this is 2-inch. And then comes down to the pickup for the laser cutter engraver. I want to come as close to the laser cutter engraver as we can with the 4-inch duct. The exhaust fan creates a lot of flow, not a lot of suction. And by forcing the air through the smaller diameter hose, I think we're actually losing out on a lot of airflow. So that's going to be like a bonus if we can get all the way down to the laser cutter engraver with essentially the 4-inch and then reduce it, right where we actually pick up the air here. Okay, so I think the first step is to start the design work on that physical valve that I want to mount here that's actually going to block off that airflow. So I'm going to go do that and I'll bring you guys back. All right, guys, and here is the design that I came up with for this. And overall, it is very similar to the common blast gate that you would have in, say, like a dust collection setup for woodworking. I did consider trying one of those first, as I did find some that were already set to go for wall mounting, but they looked a little on the flimsy side, and most of them seemed to be made out of 2 pieces, and it really wasn't clear how tightly fitting all the components were. And I'm not worried about just losing a little bit of vacuum flow like you would in a dust collection setup. I don't want any backflow of air through this guy at all, summer or winter. In the summer, I already know I'm going to have humidity problems inside the laser cutter engraver if air does get in there. And in the winter, clearly I don't want cold air coming into my basement. So I really designed this one as a monolithic piece for the main body so that I could have the tightest tolerances possible for the sliding component. And I talked about retention as well. If I pull this piece out, we see the back of it is actually wider than the front. And if I lop off the top of this guy, you can see there is a matching component to that in here. So this piece can only be inserted from the back. And then when you pull it forward, it can only come as forward as, well, let's see here. If we slide this guy back in right about there, it will stop there where it completely clears the opening, but we can't pull it all the way out, and it stays nice and aligned that we can put it back in. And in putting it back in, we're essentially stopped by the wall itself, because this is an open slot when this is not mounted to the wall. But as soon as this is screwed to the wall, now we can't back the piece out as well. If we do need to get it out to clean things out in the future, obviously it's not that big of a deal to just unscrew this from the wall and then slide this piece out from the back to clean in there. Now the reason that these are actually angled here at the end where it transitions and necks down rather than just a flat step is for printability. I am planning on printing this guy standing up on this face down here. So if I put the top back on, the only thing that should need support then is just this section here, and this section here. Obviously we're not going to be able to print that. That would be floating in midair, but those supports should be pretty easy to get off. They'll also be on the back of the part, so we're not going to see it once this guy's mounted to the wall. And yeah, we're kind of chancing it a little bit how the inside of these curved faces are going to print, but from my experience, particularly on a large curve like this, I think it's going to be okay. And where we neck down, it'll have no problem printing that. So imagine this guy is going to be standing up like this. So when it gets up to where it needs to neck down, it should have no problem with that overhang. It's just like a 45-degree overhang. And then it, comes out the necked down size versus the slot on the back. So again, this piece will have to be inserted from the back, but then once it is essentially trapped in there. So, all right, I'm going to print this out and I'll bring you guys back. All right, guys, both these pieces completed successfully, and I'm really happy with the results. I only had supports enabled for on the bed, and this guy printed face down like this, which means it supported this section here and this section here, but there was no supports inside. And that is pretty clean, especially when you consider that we are still in the midst of overhang gate. I don't know what anyone's calling it, but if you're not familiar, there is a bit of a conspiracy going on right now around how Prusa slicer and slicers that forked off of Prusa slicer slice overhangs. In short, Prusa slicer had a bug where they were utilizing the speed that was set for bridging for overhangs, and that's going to give you pretty poor overhang performance, and they did figure that out and they patched it. Now, there's a bunch of other projects that are forked off of Prusa slicer. Probably the two most well-known ones are Bamboo Studio and Orca Slicer, which Orca Slicer itself is a fork off of Bamboo Studio. Now, to be clear, the onus is 100% on any of those projects that originally forked off of Prusa Slicer to go back and occasionally make sure that there aren't any huge bugs that were fixed that they might want to consider implementing for their own code base. Like, that is not Prusa's responsibility. I would certainly not expect Prusa to proactively reach out to their competitors and say, hey, remember when you forked our code base and made your own software with it? Yeah, we had some issues and we corrected them. You might want to go check them out. No, 100% not Prusa's responsibility. However, it's a little suspect when they went and launched their Mark IV's printer and raved about how its overhang performance absolutely crushed the competition. Now, to be fair to Prusa, they're a big company. It's possible that one hand just didn't know what the other hand was doing, and they didn't realize that the overhang performance of their Mark IV's was only so good in comparison to the competition because no one else had patched this bug yet. However, the other alternative is certainly possible as well, where Prusa darn well knew that their competition hadn't patched that yet and figured that they would brag about that overhang performance and sell a bunch of Mark IV's printers before the competition figured it out and quietly fixed it on the back end. Unfortunately, if that was the plan, that's not how it played out because, of course, the community figured it out first. And yeah, it doesn't look great for Prusa right now. Again, I want to give them the benefit of the doubt. It's just the optics of it really don't look great right now. Now, if you want to know more about this, I will link to a video down in the description from Robert Cohen. It is an awesome video that goes into much more detail than I just did and is actually the video where I got most of my information from. So Robert, if you're watching this, thanks so much for that video and all the work that you put into getting to the bottom of that. All right, enough talking about that drama. Let's see if our parts actually fit together. No, it's got to go in from the back. Yeah, as soon as we get our full width section back here, that seems to tighten up nicely. If anything, it's actually, yeah, I think it's too loose. I think we're going to have air leaking past it. So that's easy to fix. We don't necessarily need to reprint this. We can just print a thicker one of these. However, actually holding this one in my hand, I think we went too thin on this cross section. I was really trying to minimize the amount of material that we used and also how long it was going to take to print, but I just think I went too thin. I think if this was only like this deep, I think that would be okay. But at this depth, I think we just have too much leverage out here. Think about it. If we have, so when this is screwed in, if we are pushing up or pulling down on this, we only really have the distance from where the screw is to either corner. So if we're pulling down, it's the distance between the screw and this corner. If we're pushing up, it's the distance between the screw and this corner. So I think we just need to widen this base out a little bit to give this guy some more stability. It's going to look real chunky if we do that, but it is what it is. I do want this to be nice and stable, and I don't want to create other failure points here by just increasing the width of the feet and not the rest of it. So I'm going to go make a thicker one of these, and I am going to go, I guess, make a thicker one of these as well. So I'll get those printed. I'll bring you guys back. All right, version 2 complete. Let's try it. Yeah, I think that's the right width on this base. Even if I just sort of just push down with my thumb and forefinger on the base here a little bit, it takes a fair amount of force now for me to rock this, whereas if I bring the old one back in, if I push down with my thumb and forefinger here, yeah, there's like no stability there at all. So I think even though that's such a minor difference overall, it is the difference that we needed for stability on this guy. Let's see how this fits. Oh, it's actually getting really tight. All right, we might have gone too far. See if I can actually just get it all the way in there. No, it's going to get stuck. It's too tight. Doesn't really seem to tighten up, so it's tight there. I know you guys can't feel how tight it is on camera, but that's probably okay. I bet that would loosen up enough there. But it's getting a whole lot tighter as this rear section gets in, which does not make a lot of sense. Oh, you know what? It might actually just be, let me clean up this edge. I think it might actually just be the infill pulled up a little bit at these ends. And I think it's thicker here at the end than it is here. Actually, let's measure it. So calipers generally have this cutout up at the top, which is really valuable for checking, well, what I'm about to check. So if you put them on the material like this and close them up, you're avoiding measuring that edge. And if we avoid measuring the edge, I'm just going to move it around a little bit in there. This measures out to 3.34. If I measure the edge, I'm going to do the same thing. Yeah, you see how it's thicker there. And if we measure across, we'll get the thickest of this edge or this edge. Like that. Yeah, it's even thicker, 3.4. 3.42, 3.4, we'll call it 3.41 versus 3.34. So I think that's what's going on. Let me clean up this edge. No, it's still really tight. I wonder if I just need to clean up all the edges. All right, I got a bit more aggressive with my cleanup. Let's see if that makes a difference. No, it's still really tight. In case you guys are screaming at your screen that I just made the whole thing too thick, I don't think so, because if I take a corner of it, if I take all four corners now, they fit into there just fine. Let's try the front. And that was a little tighter. All right, I've been messing around with this off camera for a while. It took me a good bit to figure out what was going on. I do now have a really, really good sliding fit on this, and these are the same two pieces. I haven't reprinted anything. What it ended up being is, so it's really hard to see. Yeah, I mean, maybe if I put, hold on. So I don't know if the camera's gonna pick that up, if you can see down inside of there, but basically, the inside of this, as we go down through, there were slight variations, probably because the layers started and stopped in different directions, and there was tiny misalignments in that, so that the two corners going down to this side and to this side were just not perfectly square. So what I ended up doing was just taking this file, because this one is thin enough to fit through the whole slot, and then from the back, just holding it tightly against either the top or the bottom, and just working it back and forth to square that up. And once I did that, yeah, now that is a really nice fit. It still has enough friction that I'm not worried about it moving on its own. And I think it's going to seal up really, really well, but it is 100% easy to move. Okay, with this all set to go, I think the next thing to think about is how we reduce from 4-inch down to 2-inch, where it goes into the laser cutter engraver. Now, we already have a reducer. In fact, I think we had designed that as part of that previous episode where we made the mount for the vent fan. But I'm thinking that we're going to have much better airflow if, instead of having the bend in the 4-inch flexible duct at the bottom, that we have the bend in a smooth section of pipe, and we can just integrate the reducer right into that. So imagine the top of it is coming straight down the wall. It is 4-inch. It's 4 inches all the way through the 90-degree bend, and then next down to 2-inch. And then we'd only need like a short piece of that 2-inch duct to go right into the cutter engraver. So I'm going to go see if I can model that up, and I'll bring you guys back. All right, and here's the design for that, and I think I was able to do it pretty much exactly as I described. We started with a 4-inch piece of pipe at the top. We've got the 90-degree bend in it, and then it necks down to a 2-inch section, and I've got a little lip here just to make it easy to hold on to as we're pushing the 2-inch section of duct on there. And if I whack this geometry, you can see we've got a nice smooth transition where it does neck down into the smaller size. Now, printing this is definitely going to be a challenge because there's no good smooth surfaces to have down on the bed, but what I'm thinking about doing is basically turning it like this and having sort of this face down here as the face that's on the bed. We'll end up with a bunch of supports for the first part of this curve, but if we do that, everything up here should print with no supports because we've got this little neck here with a 45-degree transition coming up. And I think this will all print just fine up here, pretty much just like those curves did on our blast gate. And then, with this bend here and this bend here, once we get past sort of this lower portion down here, it should, again, print pretty cleanly with no support. So I'm going to try it that way, and I'll bring you guys back. All right, and a couple hours later, that is done. So I think we have everything we need now. I think it's time to go back into the dark, dreary basement and start trying to fit this stuff up. Well, guys, this looks great. And if actually cutting the zip ties is indeed an indicator of permanence, it is now permanent. And I'm really happy with how I was able to sort of square everything up with having this come down the wall, and everything fit together great. And if you're wondering why I did not have a hard connection between the reduced side on this elbow and the outlet on the laser cutter engraver, this guy does shake around a little bit when it's going real fast, and this stuff, while flexible, it is a little bit sort of, it's more rigid than flexible, and I just thought it'd be nice to have just a flexible connection there where the two meet, so that the movement of this is not yanking on this guy all the time. And if we turn our fan on here and we open up our valve, I know it's totally arbitrary, but I swear there is a lot more air getting sucked into the intake back there. It could just be my imagination, but it feels like we have a lot more airflow. So I do think bringing down the 4-inch all the way to right where we go into the cutter engraver really did make a difference. Guys, as always, thanks for hanging out in the shop and this week the basement with me for this week's design and build. This has been a long time coming, getting this straightened out, and I'm really happy to have it done. Now, if this is your first time here on the channel, this is all we do. It's all functional prints. It's more the design and engineering side versus just printing silly trinkets. So if you're into that sort of thing, check out some of the other videos on the channel. If you do, you see what you like, hit that subscribe button. And guys, if you do, I'll see you next Friday.